Hello students, as in the last lecture, we had covered some sums based on the exercise number 2.2. So now we'll see the few more sums which are there in the exercise number 2.2. The sums based on prove that. That means you have to show that left hand side equal to a right hand side. Okay, so we'll take some few sums as these are the question number I guess 15, question number 15. Okay, so in the question number 15, there are more than 10 to 12 sums. Okay, the question number 15, there are 10 to 12 sums. So where we'll take some selected sums and we'll see how to prove that left hand side equal to right hand side. Okay, so here the first one is what? 1 plus tan square a plus 1 plus 1 upon tan square a equals to 1 upon sine square a minus sine raised to 4a. Now I will show one hint to solve this types of sum easily. The first hint is what? Try to convert the things a given function, trigonometric function, in sine and cos. To make the sum easy, try to convert the sum into sine and cos. If the question it is in tan, cot, sec and cosec. This is the first hint. Try to convert into sine and cos. It will make the sum more easy. If you convert whenever it is in tan, cot, sec, cosec, convert into sine and cos. Then after that, suppose if you come across there are terms like here numerator upon denominator, then here plus numerator upon denominator. Suppose here the connection is plus or minus. Here some functions are there, trigonometric functions, and here we have plus and minus. So whenever you come across the sums like this, numerator upon denominator, and here the connection is plus or minus, there is only one simplest method: do cross multiply. So keep this 2 point in your mind. First, point number 1, try to convert into sine and cos whenever you come across tan, cot, sec and cosec. And point number 2 is what? Whenever we have some function like this and then connection is plus or minus, do cross multiply. Point number 3, okay, you must know to apply the suitable formula, when to apply the reciprocal formula, and when to apply the identities formula. So reciprocal formula means what? Sine theta equals to 1 upon cosec theta. Yes or no? Cosec theta will be equals to what? 1 upon sine theta. Then cos theta will be equals to 1 upon sec theta. Sec theta will be equals to 1 upon cos theta. Okay, then tan theta will be equals to 1 upon cot theta, and cot theta will be equals to 1 upon tan theta. Then there is one more formula, that is tan theta will be equals to what? Sine upon cos, and cot theta we can write as what? Cos theta upon sine theta. So these are the inverse reciprocal formula. And identity formulas are what? Sine square theta plus cos square theta equals to 1. Sec square theta minus tan square theta equals to 1. Then cosec square theta minus cot square theta equals to 1. Here this can be written as what? Cos square theta equals to 1 minus sine square theta. Yes or no? And sine square theta we can write as 1 minus cos square theta. Similarly, here also we can make the formula for sec square and tan square. Yes or no? Like sec square theta we can write as what? 1 plus tan square theta. Yes or no? And sec square theta minus 1 equals to tan square theta. Similarly, here also we can make the formula for cosec square theta and cot square theta. Okay, so this will play an important role: reciprocal formula and identity. Okay, so whenever you have to show that left hand side equal to right hand side, so basically we use this concept to prove left hand side equal to right hand side. Okay, and so in the majority of sum you will see reciprocal and identity formula only. Okay, so just keep this 3 point in your mind whenever you have to solve such types of sum. Okay, so first one, try to convert into sine cos. Whenever you have numerator upon denominator function like this, just simply do the cross multiply. Okay, and apply the suitable formula. If you feel that we can apply the reciprocal formula and you can find the answer, then apply reciprocal or else identities. So let's begin with the first one. So here the first one is what? Okay, here we have the left hand side and right hand side. So basically in majority of the sums, as we know that this types of sums, it was there in 10th standard also. So basically we used to take the left hand side only. We prefer left hand side, yes or no? So here also, so we'll take left hand side. It is not compulsory that you have to take the left hand side only. You can take left hand side to show right hand side. You can take right hand side also to show left hand side, or else you can do both left hand side, right hand side simultaneously also. Okay, so but in 90% of the sum, basically we prefer left hand side only. Okay, so here also we'll take left hand side. So left hand side is what? 1 plus tan square a. Okay, and 1 plus 1 upon tan square a. Okay, okay, so for this sum there are 3 4 different method. Now it is on you. If you feel that if we can solve this part directly, like 1 plus tan square, 1 plus tan square is what, sec square, yes or no? So there are 3 4 different method, but the simplest method is what? As I told, first try to convert. If the question it is in tan, cot, sec and cosec, try to convert into sine and cos. And if you come across a function like plus or minus, the connection is plus or minus between the function, straight away do the cross multiplication and then proceed the step further. Okay, so here also we'll try to convert this tan into sine and cos. Okay, we'll stick with the our int and method. Okay, as I'm not saying there is only one method, that converting into sine and cos then only you will get the answer. No, there are 3 4 different method. Okay, um, there is one more shortcut method also. Just in 3 4 step you can able to solve your sum, but we'll stick with our proper method and technique. Whenever you come across tan, cot, sec, cosec, so basically we'll convert that function into sine and cos and then we'll proceed our step further. So here also we'll do the same thing. So we'll convert this tan square as sine square a upon cos square a. Here also tan square a we can write as sine square a upon cos square a. Okay, so here nothing is there, so we can write as 1. Cross it, so here you will get what? Cos square a plus sine square a upon cos square a. Okay, so here can I shift this cos square in the numerator? Can I write this step as cos square a upon sine square a? Yes or no? Then after this we'll keep this step as it is for a while. Okay, upon cos square a. Here also nothing is there, so we can write as 1. As there are function and the connection is plus and minus, so we know that simply what we have to do cross. So here you will get what? Sine square a plus cos square a upon sine square a. Yes or no? Then we know that sine square a cos square a is what? Sine square cos square a is what? 1 upon cos square a. Yeah, what is the connection? Multiplication. So you will write multiplication. Again sine square plus cos square, we know that it is 1 upon sine square a. Yes or no? Here we had replaced this sine square theta plus cos square theta by 1. So here you will write the reason. Okay, after this, as your multiplication is there, so 1 ones are, it will be 1 upon, this will be cos square a into sine square a. Okay, now as in the right hand side, clearly we can see that in the numerator we required what? 1. So here we got 1, yes or no? But in the denominator we required the terms in sine. The answer should be in sine, but here we have sine as well as cos also. So now, as now we required the denominator term in terms of sine, the whole section it should be in terms of sine. Okay, so here cos square there is no need, so we'll try to convert this cos square in terms of sine. So we'll see whether we have any relation between cos square and sine square, means we can convert cos square cos into sine. Yes, there is one relation. The relation is what? Identity relation. Yes or no? We can write cos square theta as what? 1 minus sine square theta. Yes or no? So in place of cos square we can write as what? 1 minus sine square a into sine square a. Yes or no? So 1 upon, as clearly we can see that in the denominator we required the whole section it should be in sine. So that's why I eliminated this part. I converted this cos square in terms of sine. So check, you have to guess the formula. Is there any relation between sine to cos? We can convert cos to sine or sine to cos. Yes, there is one relation, that is identity relation. Here in reciprocal, sine will get converted into cosec, not in cos. Yes or no? So you must know which formula we have to apply, whether we have to apply the reciprocal formula or identity formula. So basically 90% of the sums are based on what? Reciprocal or identity. Okay, and the rest, as I told, try to convert into sine cos and then cross multiply. This will be the basic steps. Okay, then after that simply do the cross, bracket open, bracket expand. So here you will get what? Sine square a minus sine square, here you will get what? Sine raised to 4a. Yes, here we got our right hand side. Can you see? In the numerator here we have 1, then sine square a minus sine raised to 4a. Yes, here we got our right hand side. So this was the method. In this way you can present your sum. I'm not saying this is the only one method in which you can able to find your answer. There are 2-3 different method. There is one easiest method also in which you can able to solve the sum in just 3 to 4 step. But I feel this will be the safer step, safer method, where simply what you have to do, whenever you come across the sum like tan, cot, sec, cosec, try to convert into sine cos. And then point number 2, whenever we have function and the function is connected with plus or minus, do cross multiplication and apply the suitable formula. Wherever you feel we can apply reciprocal, then apply reciprocal formula or else identity formula. I hope you all understood the first sum. Okay, so now let's move on to the next question number 2. As here in the question number 2 it says that what? In the left hand side here we have sine theta upon 1 plus cos theta, then plus 1 plus cos theta upon sine theta, and then you have to show that it is equal to 2 cosec theta. Again same, we'll take left hand side. Okay, so the left hand side is what? Sine theta upon 1 plus cos theta, 1 plus cos theta upon sine theta. Okay, so as I told just now only, whenever we have the sum it is based on tan, cot, sec, cosec, try to convert into sine and cos. Already the question it is in sine and cos only. Yes or no? Then after that, whenever we have function numerator and upon denominator form and then it is connected with plus or minus, so simply what we have to do, we have to do cross multiplication. So here what we'll do, we'll cross it. So sine into sine, here you will get what? Sine square theta. 1 plus cos, 1 plus cos, 1 plus cos, 1 plus cos. Can I write this as 1 plus cos the whole square? Yes or no? Here this will be what? 1 plus cos theta into sine theta. So I hope you all understood the step number one. As already the question, it was in sine and cos, and the connection was plus one minus, so we added the cross multiplication here. So sine and sine will be what? Sine square, and here 1 plus cos we can write as what? 1 plus cos theta the whole square, and the denominator part will be same. After this, sine square theta, this look like what? A plus b the whole square formula, so which we can write as what? A square plus 2ab plus b square. Yes or no? The denominator part will keep as it is. Then after this, clearly we can see that this sine square plus square theta plus cos square theta, in place of sine square cos square we can write as what? 1, and we'll keep this 1 plus 2 cos theta as it is, and in the denominator section also same as it is, into sine theta. So here we'll write the reason sine square theta plus cos square theta is equals to what? 1. After this 1 plus 1 is what? 2 plus 2 cos theta upon 1 plus cos theta into sine theta. Yes or no? Now after this, as clearly we can see that here 2 is common, so we can bring 2 as common. So inside the bracket you will get what? 1 plus cos theta, and here in the denominator we have 1 plus cos theta into sine theta. Yes or no? As clearly we can see that 1 plus cos, 1 plus cos is same, so we can cancel that term. So you will be left with what? 2 upon sine theta. Yes or no? So can I write this 2 upon sine theta in the next step as 2 into 1 upon sine theta? And we know that 1 upon sine theta actually it is what? It is cosec theta. So in place of 1 upon sine theta we can write as what? Cosec theta. So that is your required answer. That is your right hand side. So I hope you all understood this sum also, the second one. Okay, so here the int is very simple. Whenever you come across tan, cot, sec, cosec, try to convert into sine and cos. When the function it is in numerator and upon denominator form, and it is connected with plus and minus to cross multiplication, apply the suitable formula. Wherever you feel reciprocal, apply reciprocal formula, or else identity formula. It is on you. Okay, then after that we'll see the next sum. Let's move on to the next one. Now here the next sum is what? Cos square a minus 1, then cot square a plus 1 equals to minus 1. So we'll take the left hand side here also. So here the left hand side is what? Cos square a minus 1 cot square a plus 1. As clearly we can see that cot square a plus 1, as we can make here two formulas with respect to cosec and cot. So with respect to cosec square theta it will be what? 1 plus cot square theta, and with respect to cot square theta it will be what? Cosec square theta minus 1. As clearly we can see that 1 plus cot square theta actually it is what? Cosec square theta. So in place of cot square a plus 1, can I write directly as cosec square a? Yes or no? Or else convert this cot square into sine and cos. As I told, whenever you come across tan, cot, sec, cosec, try to convert into sine and cos. It is on you. Okay, as I told, there are 3-4 different method in which you can able to find your answer. As I feel for this sum, uh, directly we are getting the answer, the identity formula, that is cot square a plus 1 we can write as what? Cosec square a. Or else first convert this cot into sine and cos, then proceed your sum further. In both the cases you will get the same answer only. Okay, now after this, cos square a minus 1 cos square a minus 1, no, here we don't have any formula like this. we have 1 minus cos square theta equals to sin square theta. But here we have what? Cos square theta minus 1. Yes or no? So here can I do one thing? Can I bring minus sign outside the bracket? Can I write this as 1 minus cos square a? Yes or no? Bracket open and check. This will be minus 1 minus minus plus cos square a. Then keep this minus as it is. 1 minus cos square a. Now with this 1 minus cos square a we can write as what? Sin square a. Yes or no? Into cosec square a. Yes or no? And we know that there is one relation between sine and cosec. What is the relation? Sine theta is equals to 1 upon cosec theta and cosec theta is equals to 1 upon sine theta. So here can I write this cosec square theta as 1 upon sine square a? Yes or no? Here sine square will get cancelled. So here we left with what? Minus 1. So that is your right hand side. As I told, there are three different methods for this sum also. I felt this will be the easiest method. Simply in place of cot square a plus 1 we can write what? Cosec square a. Bring minus sign outside, so 1 minus cos square a we can write as what? Sin square a. And we know that there is a relation between sine and cosec, that is sin theta equals to cosec theta and cosec equal to sine. So convert this cosec into 1 upon sine, cancel. So here we got our right hand side. Okay, I hope you all understood the question number third also. So let's move on to the question number fourth now. So here the question number fourth is what? We'll take the left hand side. So here the left hand side is what? 1 plus cot theta minus cosec theta and 1 plus tan theta plus sec theta, and we required it should be equals to what? 2. So here clearly we can see that the sum it is in sine and cos, cot, cosec, tan and sec. So whenever you come across the sums based on tan, cot, sec, cosec, try to convert into sine and cos. So here we'll convert cot, cosec, tan and sec into sine and cos. So here cot we can write as what? Cos theta upon sine theta. Yes or no? Cosec we can write as what? 1 upon sine theta. Okay. 1 plus tan we can write as what? Sine theta upon cos theta. And sec we can write as what? 1 upon cos theta. Okay. Then now after this, here we have sine in both the section and here we have cos in both the section. Can I make the denominator same for both this part? So here we require sine, so we'll multiply the numerator and denominator by sine just to make the denominator same and to make the step more clear and easy. Understood? We'll convert this whole thing into sine. We'll make the denominator same. To make the denominator same, here we require sine. So what is the rule? If we required sine here in the denominator, so we have to multiply the numerator also with the same term. So the same thing here we did, multiply the numerator and denominator by sine. So as now clearly we can see that the denominator is same. So in the next step we can write this denominator one time, and here we have sine theta plus cos theta minus 1. So same fundamental will apply here also. So we'll multiply here this term by cos theta, numerator and denominator by cos theta. So 1 plus sine theta upon cos theta plus 1 upon cos theta. Okay, so here also the denominator is same, so we can write this as one time. So here in the numerator we left with cos theta plus sine theta plus 1. After this, as when you will focus on this part, sine cos, here also we have sine cos, then here we have 1 and here also we have 1. So can I consider this part, this section as a? this section as A, and this section as B, one as B. So this look like what? A minus B, A plus B, yes or no? We'll consider sine plus cos as A, sine plus cos as A and 1 as B. So replace this sine plus cos as A and 1 as B. So this part, this section look like A minus B and A plus B. And we know that what is A minus B, A plus B, we can write as what? A square minus B square, yes or no? So your A part is what? Sine theta plus cos theta, yes or no? That is A, as here multiplication relation is there, so we can multiply the numerator part and we can multiply the denominator part. So here you will get sine theta into cos theta, yes or no? Okay, so now, so here just replace this sine theta plus cos theta by A and 1 by B. So this section look like what? A minus B, A plus B. So A minus B, A plus B, we can write it as what? A square minus B square. So your A part is what? Sine plus cos, so we can write as sine plus cos the whole square, minus B part is what? 1, so 1 the whole square. So A minus B, A plus B, here I wrote A square minus B square. I hope you all understood this step. Okay, now after this look like what? A plus b the whole square formula, yes or no? So what is A plus b the whole square? A square theta, yes, A square plus 2ab plus b square. 1 square is what? 1. So in the denominator here we have what? Sine theta into cos theta, yes or no? Then after this, as here clearly we can see that sine square plus cos square we can write as what? 1, and we can keep the remaining section as it is, yes or no? Because we know that sine square plus cos square, it is what? Sine square theta plus cos square theta is equals to what? 1, yes or no? So in the next step, this 1 we can cancel as it contain opposite symbol. So you'll be left with what? 2 sine theta into cos theta, and in the denominator we left with sine theta into cos theta. Here also we can see that sine and cos, it is common, so we can cancel this part. So you'll be left with what? 2. So 2 is what is the required answer, that is your left right hand side required answer. So here we got the right hand side answer. I hope you all understood this sum also. So here exactly what I did, I converted the whole section into sine and cos. Then after that, instead of doing here cross multiplication, as we know that whenever the function it is in numerator upon denominator form, just now only I told, and the connection is plus or minus, we can do one thing, that is cross multiplication. So here instead of doing cross multiplication, what I did, I made the denominator part same. So we know that how to make the denominator same. Okay, then after that, here the denominator it was same, here also it was same. So in the numerator part, this look like a plus b and a minus b, and we know that a plus b, a minus b we can write as a square minus b square. And then after that, we know that exactly what exactly we have to do. This look like a plus b the whole square. Apply the formula. Sine square cos square, it was 1, 1 get cancelled. So here we left with 2 sine theta into cos theta. So here also sine and cos will get cancelled, so here we left with what? 2. So in this way you can frame, you can find your answer. I hope you all understood the sum also. As now we had did 4 sums. This one, I hope you all understood the first sum also, second as well as third and the fourth one also. Okay. So as I told in the question number 15, these are the question number 15 sums, in where 10 to 12 sums are there. As we took the 4 sums and we saw how to uh, apply the fundamental, how to proceed the steps, what are the techniques to frame the answer, yes or no, how to show that it is equals to right hand side. Basically, as I told, in majority of the sums we have to use the reciprocal or else identity formula. So these are the 2 points which you have to keep in your mind whenever the sum it is based on tan, cot, sec, cosec, try to convert into sine and cos just to make the sum more clear and easy. It is not compulsory that you have to convert into sine and cos. Okay, the hint number one is just to make the sum more clear and easy. And whenever the function it is in numerator upon denominator form and the connection is plus or minus, do one thing, that is cross multiplication. Okay, rest I hope you all understood the first four sum of the question number 15. Okay, so the remaining sums, remaining part we'll see in the next lecture.